Hi guys, welcome to my YouTube channel. I'm so excited. This is the first video that I'm making for this channel. I hope you guys are also excited and will learn something out of what we're doing today. So I thought I'd start with microeconomics, specifically looking at the Marshallian demand function. I've already put up the utility function and the budget constraint. And basically what we'll be doing today is to derive the Marshallian demand functions for both good X and good Y. So before we get started with the derivation, I just want to explain why we derive the Marshallian demand function to begin with. So in this specific example, you've got an agent that makes an income, or let's say gets an allowance and faces a budget constraint. The agent has a choice to make between buying good X and good Y, or buying a certain number of good X and good Y, given the prices of each good, and they have to make the decision in a way that maximizes the total utility. So this is a utility maximization problem given the prices for both goods and your income that you have. So let's get started. So I've written down the Lagrangian. I think if you're in postgrad, you already know how to do this. It's quite simple. You just plug in your utility function and your budget constraint with the multiplier. And what we're trying to do basically is to get the first order conditions for your x, y, as well as the multiplier, which is lambda. I'll also do that quickly. I won't go through it step by step. If you feel this video is a bit fast, I think you can just pause it and um, go through it at your own pace. So we've got our three first order conditions. I'll just call this 1A, 1B, and 1C. So basically, I've just used the chain rule on the derivative for x and the derivative for y. And just to mention two things before I forget, the P, it might look like a P. It's not really a P, it's a row. I just don't know how to write it properly. And yeah, I forgot the other one. But anyway, this is what you need to do. And after this step, all you do is you divide your first order condition for x with your first order condition for y. I'll do that quickly. So yeah, before I do that, I think the best thing to do, it's a bit messy. So to clean it up a bit, we can just cancel what we can, and then we can divide it out. So we've got these two similar terms that will cancel out, and the lambdas will also cancel out, and we'll basically be left with these two that we can cancel, or sorry, that we can multiply out, cross multiply in order to solve for x, get x on the left hand side by itself, and also get y on the left hand side by itself. Just scroll up. So we've divided a by b. Now we can just cross multiply to get this. So I've taken everything to the right hand side and got an x by itself on the left hand side. Remember, the y was inside the bracket, but when we bring that 1 over rho minus 1, it actually cancels out and you've got y to the power of 1, and that's why I've got it by itself outside of the bracket. And now, just to make things easier, this is going to make everything a bit messy, so we can just try to simplify and say let 1 over, can just put it the other way around, 1 minus rho be equal to sigma, and everything that has 1 over rho minus 1 will just make it a negative sigma. Let me just write it out so it's clear. Yeah. So now that we've done this, if we want everything to the power of positive sigma, that means alpha and py will have to go up. We can move things around and get this. So this is very important because this is what we're going to use to get our x, our Marshallian demand for good x. So I'll just call this equation 2. This is what we're going to use. Basically, we're just going to plug in our y here. But before we do that, before we plug in our y, we're going to have to express y in terms of the budget constraint. So remember, we said that our budget constraint is px, price of x times good x plus price of y times good y is equal to your income. And to get y on its own, we can just plug in x and say px, remove the page, px to the alpha, 1 minus alpha, py px. So remember, this is all x plus pyy is equal to our income. So we're trying to get y by itself, so we can just take the common variable out and we'll be left with everything else that does not include y. So this will go to the other side. We've got this. So yeah, now we've got y, and this we can call 3. This is also important. So remember, we had gotten our x, which is equal to this right here, and now we've got y. So what we just need to do is to plug in this y right here, and we'll have our Marshallian demand for good x. So as easy as that. Let's do that quickly. Let's say that x equal to saying times y, right? So this is this that we've got right here. Can just put a bracket here so it doesn't look too messy. And just trying to rearrange everything. So you can, if you want, you can keep it this way, but we're trying to get the Marshallian demand of good x. So we'd want to ideally express this as a function of the price of good x. Just to clean it up a bit, what I will do is to get rid of these denominators, bring them up, which will basically change the sign. Let me see if I did not forget anything. I don't think I forgot anything here. Let me just go up a bit and see. X is equal to this. Y we said is equal to, oh yeah, pxx. We forgot this here. The sigma, I think we lost it somehow. So we can just plug it everywhere. So now we've got this. So we're going to try to get everything that's at the bottom on top, so we don't have a denominator over another denominator. So we're going to try clean it up a bit. So I'll do that quickly. Let me just make sure I did this correctly. So the reason why it's so long is because I've brought everything up. So we've got the p price of x, that's the power of 1. Our alpha is the power of sigma. Our price of y is to the power of sigma. Our 1 minus alpha is to the power of minus sigma, since we're bringing it up. Our price of good x is to the price of minus sigma, since we're bringing it up. Yeah, that seems fine. Can do this so we can see everything. Okay, so now we can clean it up a bit further. Can multiply these two out. And just to get to, so let me say we've got alpha. Alpha is to the power of sigma. Our px, what else do we have here? We've got px, price of x to the 1, and here's another one, so it'll be price of x, 1 minus the sigma. Price of y will cancel out, 1 minus alpha will also cancel out, so that's fine. And this side we've got 1 minus alpha to the sigma, price of y to the 1. We've got 1 here, so it'll be price of y, 1 minus sigma. This should be correct. Just want to double check my solution. Yeah, it should be correct. So this is our Marshallian of good X given the price of good X as well as our income. So that's pretty much it. That's all you do. And now we'll just continue to get our Marshallian for good Y. But basically, we're doing the same thing. We just going to get our Y on the one side and our X from the budget constraint. So remember, after dividing our 1A and 1B, our first order conditions, this is what we got. So now trying to get Y on one side. This is price of Y. I don't want to confuse it. Just write a small y here. It's not a standalone y, so it's the price of y. So anyway, if we move this around, we are going to get this. And remember we said that 1 over rho minus 1 is negative sigma. So if we move things up, we're going to get a positive sigma. So we can do this. So this is our y. And now we just get x from our budget constraint. A reminder that our budget constraint is px of x plus price of y times y, which is equal to our income. And we are trying to get x. So we'll just substitute y. So this is all y equal to m. Okay, so we've got that, and now we just want to get x on one side. Can just do this. X is common, so you can get it on one side. So this is our x. I think when we're numbering our equations, we had 3 and 4. This was 2, this was 3. Okay, so this we can call 4. This is our equation 4. Sure, this pen is really acting up. So yeah, this is 4. And now that we've got our x, we can plug it into our y. This is the y that we've gotten. Yeah. So anyway, Yeah, so this is our x. We can call this, I think this should be 5 because it also got an y. Y will be 4. I think the other one was 3, yeah. So we've got 4. We've got the x now, which is our 5, that we want to substitute into 4 to get our y. So here's our y, which is equal to, so this whole thing here, and we can clean it up further. To clean this up a bit, we can just do this. Express it in terms of the price of y, and we can bring down the price of x to make it a negative sigma. Same for the side um, of the equation. We can bring everything that's down, we can just bring it up so we don't have a denominator of another denominator. So we still have the 1 minus alpha to the power of sigma. The price of x is also to the power of sigma. Price of y, we're bringing it up, so it will be to the power of minus sigma. Alpha, we're bringing it up, so it's to the power of minus sigma. What we can do now is multiply out these two terms. So we have y, which is our Marshallian, a function of our prices, and our income will be equal to 1 minus alpha for the price of y sigma times our income over, if we multiply this out, the side of these two terms, we'll have alpha to the sigma, price of x, 1 minus sigma, plus multiplying these two out, we have 1 minus alpha, sigma, it's not theta, it's sigma. Price of x will cancel out. We've got a sigma and negative sigma. And alpha will also cancel out. We've got a negative alpha and a positive alpha. And we left with price of y, 1 minus sigma. Yes, so now we have both our Marshallian demand function for good x and good y. And what we've done is that we've expressed both Marshallian demand functions in terms of the prices for both goods and the income that the agent gets or the budget constraint. So basically, that's it. We've pretty much answered the question, and I hope it was clear and easy to follow. So let me know what you think, and if this has been useful, please share, like, and subscribe to the channel. And also let me know in the comments what else you want to see. So thanks for watching. Till next time. Cheers.